I saw it's 10. Okay, so let's do some more physics. We're going to graph velocity. We're also going to look at acceleration, actually right above me right here. That's a graph of acceleration. Notice how it's getting faster and faster and faster, so it curves up. Whereas velocity, which is of course a vector, right? That's why we've got the direction there, north. Velocity is constant, a nice straight line, you know, as time goes by. So on the x-axis down here, as time goes by, distance goes by, and a nice and equal. So for every second, exactly 3 meters, let's say, and then at 2 seconds, we're now at 6. And then at 3 seconds, we're at 9. So nice and even constant velocity. When we say velocity, we mean constant velocity. Okay, cool. So do make sure you've got your physics. Actually, that's my chemistry one, but make sure you've got your physics formula sheet. I'll show it to you on the screen here. Have to have a calculator. You can't do this without a calculator. And for this one, you're going to want some graph paper in it. Now, if you don't have graph paper, you can just use regular paper. But yeah, get a few sheets of graph paper for yourself. You can actually usually get it on the internet and just print it on your printer. And yeah, let's share the screen. Let's get the notes going here. Here we go. All right, so as you can see, we've got we've got our notes we're going to go over. Make sure you got your calculator. Hey, there's 9.81. That's the acceleration due to gravity. We'll be looking at that in the next few lessons. But yeah, your formula sheet's really, really critical. Again, we're going to be looking at velocity. So with the little arrow on above here. So displacement, right? So it's got to have some kind of magnitude. So it's got a distance. It still has distance, but it's got a direction, right? And then over change in time. And really, it's just a matter of making sure any graph you have, you know, says northeast, southwest, or whatever the actual direction that the vector is headed. Okay, cool. So let's maximize our screen. Yeah, have some note paper, calculator, formula sheet always beside you. And you want to get your title, graphing velocity and acceleration. So we're going to look at acceleration as well. And just some basics, you know, what does an acceleration graph look like? Hey, we already know. So, you know, we are going to start with talking about velocity here, or constant speed. So like you're on cruise control, and this is indeed cruise control right here. We'll also look at acceleration. Like I said, acceleration graph would look like this. And, you know, on this part here, we would have our displacement, right? So, you know, which includes distance. So, you know, if you want to think about that as distance, that's fine. And time, because, yeah, we might put the displacement, I don't know, we're going north here. Let me zoom in a little bit. We don't need to be so far zoomed out. There we go. And again, velocity is just a constant speed. Acceleration is faster and faster and faster, right? So let's take a look at these first two velocity graphs. I already talked a little bit about the first one there, but yeah, take a look at graph A and graph D here. First, you know, we got nice straight lines. So it is constant, right? So there is a constant speed represented by both, but this one's kind of weird. I have to think about this one a bit. So let's look here. So this one, it definitely has a nice slope. And so say for every, I don't know, let's say this is 10 meters right here. So just draw this out quick in your notes, you know, distance on the Y, saying yes, up and down, and time on the X, or left and right. Also, it makes sense to put time here, right? Because time, you know, we want it to go sort of from left to right, but traveling in the direction from the right. It just kind of makes sense for time to go that way. So say 10 meters for every, I don't know, 1 second, right? 2 seconds. So we're going to have 20. It's such a neat graph we're doing here. But ultimately, you know, it's a nice constant speed. It's a straight line. And so, you know, 10 meters per second. Velocity with the little hat symbol there, 10 meters per second. And yeah, we'll just say we're going north here. Nice constant speed. Make sure to put the little hat, the little arrow on there. This one is flat. Okay, so after 1 second, I don't know, like maybe it's just it was a meter away from you and you're watching something, okay? So something is a meter away from you, okay? All right, and you're watching it, and after a second, it's a meter away. After 2 seconds, it's a meter away. After 3 seconds, it's a meter away. Okay, it's not moving. So that's what that one's definitely not moving. Okay, so acceleration, mentioned a little bit, but think of this drag racer here, right? So look at that, just burning the rubber. That's got to be expensive. That's insane. But anyway, that's okay. It's fun, you know. You get some popcorn and have a heck of a time. So we're going to go from 0 to 150 kilometers per hour. Holy doodle, in 5 seconds. That's a lot of acceleration. I mean, to think about it, for every second, like let's just kind of think about what acceleration is, because it is faster and faster and faster. It's not just a constant speed. We're not saying that this thing is, you were watching it and you saw it come by and it's going 150, and then you watch it for 5 seconds and it's still going 150. That's not what we're saying. We're saying you watching it and it's sitting there still and you got a stopwatch, and then someone says go and you press the stopwatch, and then you know it accelerates like crazy, right? Okay, so basically this thing starts at 0 for speed, right? And also 0 time, right? Because there's always a time where we start the watch, basically, right? And all of a sudden, whatever, after 5 seconds, it's going 150 kilometers per hour. That's hugely, hugely fast. That's almost 50 meters a second, but don't worry about doing that conversion. I mean, you can check it on your own, how many meters per second that is, but that's certainly fast, right? Yep, for 5 seconds. Okay, cool. So in other words, if we have 1 second, the amount of acceleration here, you just divide this, right? So 150 divided by 5, or 15 divided by 5, right? 30. So it's going to be 30, right? So after 1 second, it's going 30 kilometers per hour already in a second. It's pretty cool. 2 seconds, it's going 60 kilometers per hour. Oh yeah, this is counting up. It's going to get up to 150, right? After 3 seconds, it's going 90 kilometers per hour. After 4 seconds, it's going 120 kilometers per hour. After 5 seconds, boom, there we go. There's our acceleration, 150 kilometers per hour. That's how we would calculate what's technically called average acceleration. A graph of this would not be a nice straight line. It would swoop up, right? It would kind of curve up. Obviously, it doesn't curve up to go to infinity speed. But yeah, that's your basic. And you know, again, remember, I don't know, so he's going north. So we'll make sure it's a good vector here. So it's not just distance. Of course, there's distance in there, right? So, you know, a certain amount of distance and then in a direction, right? So you got your distance there in meters, and then you get your time here in seconds. Always put the distance, just say yes. Yes, I will put the distance on the y-axis, and then just say I'll put time on the x, because time x, there we go, time x, time on the x. Just thought that's fabulous. Wow, that's cool. Let's look at a few acceleration graphs. I know we've already been chatting about this. I'm going to flip the slide here. Let's look at a few acceleration graphs. Okay, oh, decelerating is a form of acceleration. Basically, we're changing speed every second, either getting quicker and quicker and quicker. So it's really, acceleration is a change in speed every second. Quicker and quicker and quicker, or slower and slower and slower, right? So this might be, again, you know, you're watching somebody and you start watching them and you pick a point where to start and they hit the brakes, okay? So their speed is going to start to go down, basically. Yeah, cool. All right, so let's graph velocity. Okay, so that's just an intro. We've got a bit of an intro there into what is velocity, constant velocity, and what's acceleration. But let's actually do some graphing. I'm going to flip the slide here again. Go right here. Here we go. Okay, cool. So let's draw this with me here. So, you don't necessarily need a ruler, but it doesn't hurt, kind of making sure you can make your lines nice and straight. So let's do the y-axis up and down. Just use a book or something, or grab a ruler so you can straighten it out to your x-axis, left and right, x and y. Let's write displacement like that, right? If without the arrow, it'd be distance. Displacement includes distance, right? And so we'll just say we're going north, just to give us a direction, right? And of course, down here, time in seconds. And of course, we got a starting point. There's always a starting point, 0, right? It's when the stopwatch starts. Even if you're checking cruise control for somebody, they're driving for hours and hours down a highway, but you're kind of standing at a certain place and they come by you and, okay, I'm going to watch them for now, just like you're a police officer, you're watching them. I'm going to watch them for 5 seconds. Okay, so starting right here. Okay, start the clock. Okay, and then they drove, I don't know, they got over there to the other guy with the donut, drove by him. Okay, so in 5 seconds, I got 500 meters or whatever it is, right? So I'm not sure what speed that'd be. You'd have to calculate that. But ultimately, what we got going here when we're graphing velocity, and we're not going to put any values in this just yet. We're just going to, okay, so this would be super fast, right? Faster and faster, slower, slower, and then like standing still practically right there. So we'll just give it kind of a bit of speed here. But we have on the bottom, you got change in time, right? So time is going from 0 and then 1 second, and it's always in seconds when we do this. You might have to convert stuff, right? Because it might be given kilometers per hour, and you got to convert it to meters per second. So in this way, it's a change in time, which is actually written delta t. So that's just a fancy way of saying change in time. And in this direction here, this is distance, and of course it's change in distance. We can say distance, we don't have to keep calling it displacement because we've got that indicated up here. So we know we're going north, and so it's just, okay, what distance am I going north? So change in distance, again, it's meters. Okay, it's always got to be meters for that. And so that's delta D, right? Now we'll put that just to say that, yeah, we do actually know the direction, right? Change in distance. So of course, your velocity, like that, kilometers, right? Distance per time. So you already say this, right? You already say, oh, I'm going 30K per hour. Of course, now we got to talk meters per second, but use what you already know. Take what you already know about stuff so you can understand it. Okay, so this slope, the slope does show the velocity, right? So let's get that down. So our slope, it shows it. It represents it as we're saying here, but it shows velocity. So you can almost feel that velocity, right? So just do, some simple quick graphs, do one that's slow, make it sure it's a straight line. So nice and constant velocity, but do one that would be slow, right? So it'd be really low. Like, I don't know, we got turtle going here. Nice and slow. Okay, so we'll go fast and then we'll go very fast. So just do a fast. So you got slow already. So draw a fast one. Again, draw a nice straight line because its velocity is always constant velocity. We're not accelerating. We're going at exact cruise control speed, right? So I don't know, that'll be pretty fast there. It's definitely steeper. The slope is definitely steeper. If you were going to ski down this, which one, depending what kind of skier you are, maybe you want to be safe and not, break legs and stuff. So you'd ski down this hill. But you want to, whatever, you're extreme skier, you're going to go down this one. Well, here's the super extreme skier, the cuckoo skier. So very fast, right? Super steep slope. And I didn't mean to draw it. It's kind of bent. It should be nice and straight. So just draw it. Oh, it's just got to be steeper than my fast one. There we go. That's very fast, steep, right? So your slope is indeed your rise right there. So where you got this down, that velocity, again, with the little vector symbol, velocity, and to get the velocity off one of these graphs, get the rise, find the rise over run. Get the distance that we go on the y-axis and put it over the run. We'll get an example here, like literally just in a moment here, right now. And yeah, just let's make sure that's clear over here as well. Slope is, this is what slope is. It is rise over run. And when we're talking about velocity, well, that'll actually give us velocity. And literally by writing that, as you write the V with the arrow, start in your brain, just, hey, that's velocity. And I'm going to need a displacement, right? So magnitude and direction, change in displacement, change in distance, you can consider it, and change in time. Okay, cool. And yeah, it's going to get you your velocity. And it'll be nice, whatever that number is, it'll be nice and straight, right? That's supposed to be straight. Let's see an example. Let's put some numbers in here. Let's put some numbers in. Okay, so we got time on the bottom and on the Y. Time is on the X, time X. So distance, oh yeah, distance is right here. Draw this one out real quick. I know I got it here. But you go ahead, maybe just hit pause and get that down. All right, we're going to solve for this. So we're going to say velocity equals whatever the rise is over the run. You can compare any 2 points here, okay? So we got a rise of 4 over 1, or it can be a rise of 8 over 2. You can use any of these. They're all going to be the same. Do check them. Make sure, right? Oh, and let's make sure we're saying, okay, we're headed north here. So therefore, this is indeed displacement, right? So we're headed north, and after 1 second, we go 4 meters. After 2 seconds, we go 8 meters. Again, we can plug in any of these two as long as we're comparing the same two data points here, right? So basically, we got a rise of 4 over 1, but we could try a rise over, oops, yeah, 8 over 2. I could try this one here, 12 over 3. They should all be the same, right? Because it's just nice constant velocity. Let's see, and of course, this is meters, second, meters, second, 12 meters, 3 seconds. Okay, 4 over 1 is 4 meters per second with that line, always say per. 8 divided by 2 is 4 meters per second. Oh, okay, yeah, they're the same. They should be. They're nice straight line. This is also, and yeah, that's got to be 4 meters per second. This is a really bad S on this 3, so my massive apologies. I'll just put a better looking S there, and it's got a weird, that'll be 3.0. Okay. Let's make sure, so we got the basics here. We know how these graphs work. I think you can probably construct one now, but we're still going to go through that. Let's make sure we can read some velocity graphs so you can just describe the velocity that you see. So we're gonna show you 4 graphs now. So take a look at these 4 graphs. Look at them. Take a moment to take a look at them. You know, maybe even pause the screen and just take a look and basically describe the velocity that you see. I'm going to put a little chart together for us here. So graph A, and then your description of graph A, and of course, do the same with B, do the same with C, do the same with D. I think we've looked at a couple of these, but still, it's worth looking at each of them. Ooh, nice straight line. That's definitely velocity. So, yeah, we are, this is just constant velocity. It's nice, it's just velocity. This swooping up, that's acceleration. It's getting faster and faster and faster, so it curves up. This is going not as far with each second, right? Because if it was going exactly the same distance with each second, it'd be nice and straight. And if it was getting faster each second, it would curve up. So this is therefore slowing down each second. This is deceleration. Oh, that's kind of cool. Okay, again, you're staring at something. It's, I don't know, 2 meters from you. And a second goes by, still 2 meters. 2 seconds go by, it's still 2 meters. It's not moving. It's basically, it's still. No velocity, zero. It's good old zero. So yeah, that's exciting. Now moving. Okay, so you need to be able to read those kinds of graphs, right? You need to know distance is, of course, on the y-axis, and time is on the x, time x, right? So next, what we're going to do is we're going to make a graph, and you're going to submit it. This is actually an assignment. You can use these same numbers. You can choose different ones too, actually, as long as it's, you know, you got them correct, right? As long as basically we're looking at a nice graph. Okay, so let me switch the slides here. Well, a velocity graph, that your graph is nice and straight, right? And I've got a quick video. I'm going to show you what your final product looks like. But yeah, I mean, basically, when you're making these, use some grid paper or make some, right? Definitely you're going to want a ruler. 0, 0. Okay, and so D, but put that right there. And let's just say we're going north. If the question doesn't say where we're going, you can choose north, east, north, east, south, or west. You can choose, right? The direction. Get some kind of a scale here, right? That makes sense. So 10 meters. This is of course meters. This is of course time in seconds. Okay, so 10, 20, 30, 40, 50. Okay, just got to go to there. Oh, I could have used 2. So, but that's all right. It's looking beautiful and neat. We'll go 2, 4. It looks like we check it every 2 seconds exactly. That's kind of cool. 2, 4, 6, 8, 10. There you go. Used it pretty good. Just make a bit of a dot here, right? Let's see. It should form a nice straight line. Sure hope it does. Okay, so at 10 seconds, 2 meters. At 20 meters, 4 seconds gone by, or at 4 seconds, you've gone 20 meters. At 6 seconds, we've gone 30. Yep. At 8 seconds, we've gone 40. And at 10 seconds, we've gone 50. Obviously, on your assignment, you need to put your name, and you're going to, do it on paper and then take a picture with your cell phone and turn it into PDF and submit it right into Moodle. So I did that real quick. You're going to see a video right now, what it should look like, or right after I'm done this real quick. And of course, we want to get our slope, right, for this. Slope equals change, distance, change in time. So pick any 2 points, right? So change in distance, 10 meters. And it is a displacement because we're going north, but you can just call it distance. And we've gone 2 seconds, 10 divided by 2. I think we know what that is. 5 meters per second. You can use these exact numbers, or you can pick some different ones. Just make sure that you get a nice, that it is indeed nice constant velocity. So that'd be kind of cool. You can submit that. Okay, take a look at the quick video here so you know what your submission needs to look like. So when graphing velocity, start with your data and just put it into a table. Obviously your time and your distance. Do indicate the actual displacement. So we're headed north in this particular question. Once you get your data table, it's just a matter of putting together the graph itself. Make sure, of course, your distance is on the y-axis, and make sure that your time is on the x-axis. And yeah, once you've got it graphed out, and just use some kind of a straight edge to make it kind of look nice. Calculate your slope, your rise over run. In other words, calculate your velocity. Always make sure to use the little symbol here so that we know that it is actually a vector, right? 5 meters per second north. But yeah, make sure. Maybe I've got these calculations and numbers wrong. And yeah, when you submit it, make yours look just like this. Okay, cool. You saw what that submission needs to look like. Let's do a last reminder about velocity. Velocity, constant velocity, and acceleration. So let's do that. Let's flip our slide. Okay, so something like velocity is going to be, oops, got to get the right page here in my notes. So essentially, it's a car traveling on cruise control, right? And it could be traveling for hours and hours and hours, but at a certain point, you're going to measure it. So you're standing here, and you got like a little stopwatch, and so it's 0 meters, and it's 0 seconds, and then the car again going at a nice constant velocity. Beautiful car this is, by the way. And this beautiful car goes by you right there at 0 meters, and then I don't know, it's gone 10 meters. You stop the stopwatch, however many seconds that is. Turns out that's 10 seconds, and turns out it went 10 meters, right? Okay, so it's therefore going 1 meter per second, obviously, but yeah, that's, again, it's going nice and constant. It's not accelerating. It didn't start there. We're not saying that it started there. It's just saying that's what we measured. We measured between point A and point B. There goes. Look at that beautiful little car. It's a nice car. Versus acceleration. So the light has just turned green, right? So the light was red. The vehicle is stopped. There is a 0 time and a 0 distance, right? Write that a line. I guess he's already getting going. And whatever, you're in there in the car, and it's like, green, go! Don't speed. So this person is not speeding. They are accelerating. They are accelerating, right? They got to get up to speed. So, what is their average acceleration? Let's say they go from 0 to 50 kilometers per hour, and I don't know, it takes them 5 seconds, right? So then there's going to be an average acceleration of 10 meters per second, right? That makes sense, right? Because in the first meter, you're just going 10 meters per second. Then in the second meter, the second 10 meters, sorry, in the second 10 meters, you're going 20 meters per second. And then in the third, goes and goes and goes. Let me write it out instead of saying it. So yeah, we got this here, and basically it was at 0 seconds, and then we went whatever, 5 seconds, and of course we're at 0 meters, and now we're at 50 meters. And so basically it's going to be 50 meters over 5 seconds. 50 divided by 5 is an acceleration of 10 meters per second. There, I got it. Whew, boy. And you get it. I mean, go to a traffic light and be at 0 and accelerate your car away. You'll be good. We're going to do some more videos too on calculating problems with acceleration, but that's just kind of your intro. And the main thing was being able to really read a graph of acceleration so that it's kind of swooping up versus velocity, constant speed. It's just a straight line. So for our velocity, it's just like that. And for acceleration, We're just like that. Okay, great. Science 10. Get the graphing assignment done and submit it. Take care.